Alright, I just wanted to show this mechanical version of inverting the light bulb, just like in reference to the solid state one. Before I'm using this joule thief over here, I got it charging a little battery right now, but I was using that solid state to light that bulb up there, and I got it to get the brightest I could get it at 330 milliamps with 12 volts. And this is basically the same idea, it's just mechanical. And this is one of my favorite little pulse motors, but it's pretty simple. I just basically built a normal pulse motor setup over here, where I have a little rotor out. Preferably, I would make it as small as possible and as noisy, as least noisy as I could get it, quiet as possible. And it wouldn't really do anything other than just be a mechanical switch, you know, with a reed switch or whatever. And you know, I got a transformer over here, which is basically just driving the pulse motor circuit. And since this portion is basically just a switch, what it's really switching is this big coil over here. So basically, a primary on this big transformer is in parallel with the drive coil over here that turns the rotor. So this coil just gets the rotor going, and every time it switches, it's going to fire through this big coil. So the downside is it's going to draw more in the process of doing that, but the whole point is I just want beefy pulses. And basically what this does, of course, is just takes the pulse and it steps it up through this secondary, which I have going through a bridge rectifier, which is just what I use to charge stuff. You know, I got this CFL across the AC just for whatever purposes, protection, whatever. And I'm gonna run this right now. I got the meter on, so at its lowest setting, it draws about 50-60 milliamps, and it's not outputting enough voltage to light like the CFL or anything like that at this point from 50 milliamps, nor will it light the LED bulb. But when I cut it up to maybe about, well, let's just cut it all the way up. It's too loud for my taste, but all the way up draws about 360 milliamps, and the CFL lights up pretty good. But what I'm going to do is I'm going to take this, here's my output. I'm just going to connect the plug to this lamp that I have the LED bulb in. See, it's pretty beefy spark right there. So now it's running the LED bulb, and that's like 100% bright right there. That's as bright as it gets when I plug it into the wall. Maybe I can show that later, but it's about 370 milliamps. And you see, when I cut it down to about that level, where any lower than that is probably not useful at all, it's still about 160 milliamps. So I can't really quite say which one's more efficient. The other one drew 330 milliamps, but it wasn't quite as bright. So I would say they're about the same, you know, efficiency-wise. They're pretty much about the same. Now I could get this one probably more efficient. The main thing is just the rotor does not need to be the way that it is. It's just a switch, and of course there's losses going on, but I think this could be done if I minus this transformer and just make this entirely the drive. It will probably be a little more efficient. Yeah, it's not bad, you know. Lights it up pretty good. That's pretty bright right there. A 5-watt 100K resistor, 5K pot. Then I've got another 50K over there, 3055 audio transformer and an adapter transformer. That's all that is.